In the first video, I showed you how to set up a Raspberry Pi so that you can get the user interface that you see here, and now we're going to use that to control some real hardware. Okay, so we now have Node-Red set up with Mosquito for the MQTT on the Raspberry Pi, and you can kind of see the IDE running here that we looked at before. So what we need now is to control some real hardware. What I've got here is a Espruino Wi-Fi board. This is the Espruino Web IDE, which is dead easy to set up. Just follow the instructions when you get the board out. All you have to do is click connect, and you'll be connected to this device. You can then interact with the device itself, so you can say things like LED.set, and it'll light, and reset and turn it off. Now I've got some code here on the right hand side which will handle a really simple MQTT connection. You've got your Wi-Fi name here, your Wi-Fi password, where we're actually going to connect on MQTT, and we're going to give our device a path that it's going to respond to. I'm just calling that my device here. So all we do is when it starts up, we try and connect to the Wi-Fi. Once that's connected, we find the IP address and we then try and connect to it with MQTT. And here we do the MQTT connection, and if the connection ever disconnects, we just wait for a second and then we try and connect again. And this creates quite a nice, reliable MQTT connection if your Wi-Fi network goes down or your server itself restarts. Once we're connected, all we do is we subscribe to anything beginning with the path, which was my device. And hash, again, is a wildcard. So it's literally saying anything that starts with my device, we will subscribe to. And when it gets a message, it calls publish, which will call MQTT message, which will print that. So all I have to do now is upload this. Because we're not saving it, I need to call onInit now, just to kick it all off. Once it's saved, onInit will get called automatically every time power's applied. But now it's connecting to Wi-Fi. Once it's connected, you get an IP address and MQTT is connected. So if we take a look at sending a Mosquito publish command to just force an MQTT command to happen, and we send hello to my device/hello, it will appear here, actually coming directly from the device over Wi-Fi. In the same way, if we're responding to, if we're trying to see exactly what's being sent, the device itself can publish stuff. So if I say mqtt.publish, my device foo maybe 1, 2, 3, 4. It will also be picked up by the device itself, but if we go back to the command prompt, it'll be sent there. And this will also work on Node-Red. But if we want to do something more interesting, maybe we want to turn something on and off, all we have to do is respond in this function here. So if I say if pub.topic equals path plus set, and then I just say digital write to first LED, which is the red LED, whatever was in the message. We don't have to completely reboot, we can just replace that function by copying and pasting it. So now, if I take this and I try and send a command, my device set, and I send 1, the LED will light. And here, we'll turn it off again. Now, you might have seen a CPU temp there, and that's because I've had a interval running all the time, which will just publish the temperature that that we get from the Espruino Wi-Fi CPU. And we could graph that if we wanted. So if we want to do something with this in the IDE itself, it's actually pretty easy. Let's drag on 2 buttons for the user interface. Let's call this one on, and let's put 1 in the payload. Call this one off, put 0 in the payload. And then all we need is an MQTT transmit, which we'll drag on, and we'll wire it up, and we'll make that one go to /mydevice/set. Once we deploy that, we'll see 2 buttons. And whoops, if I turn this on, it'll light, and if I turn it off, it'll go out. Now this is not coming through USB at all. We could just unplug USB and plug a USB power back in once we've saved this, and it would work perfectly. But just turning the LED on and off isn't very helpful. We might probably want to turn on, maybe we want to turn on some mains power devices, in which case we can use something like this. This is a little relay module, so it's rated for 250 volts on this side, so you could quite happily turn on lights and whatever just by connecting them to the connections here. You can see that on the back it's got it marked where this is normally closed, so effectively between COM1 and NC will normally be connected, but when the relay is active it will instead connect common and normally open one. To connect this, all we have to do is wire it up quite simply. These usually come with a little plastic jumper connecting JD-VCC, which is the relay's coils voltage, to the VCC that we're actually going to use to activate the coils. And because this is a 3.3 volt microcontroller and this is a 5 volt relay, we want to separate the two. So this one now, JD-VCC, goes to 5 volts because it's a relay one, and then we just connect up ground, and we connect up 3.3 volts to VCC. Do that, and finally the 2 data wires here, we'll just stick those in next door, which are data pins, which are B3 and B4. So we can turn this on and off quite easily, hopefully, just by saying digital write again. These relays invert the values, so to turn them on you send a 0, and you can just see that red LED lit up there, and to turn them off you send a 1, and if I want to light the other relay up, all I have to do is send 0 to B4. So if we want to control this from MQTT, all we have to do is something very similar. So instead of /set, I'll do 1/set and 2/set. But also I want to send back the current state of the relay, because we might care about knowing whether this has actually received the data it's supposed to receive and has acted on it. So it's as easy as taking our MQTT publish and putting that, no, here we go, path 1, and we don't want to say set again because that will just trigger us off, so we'll just have 1/status, and as the status we will set the value of the of what we set the relay to. So just to make it more obvious, because you could send a message that wasn't 0 or 1 here and it would just relay the same message back if we copied that, we'll say only send the value if let's say the message is 0. So relay's inverted, so we want to negate that and we want to send back the actual value here. Then all we'll do is we'll duplicate that for the second relay. 2/set, 2/status, and we'll change the pin. And that's it. So now, if we go back into our little user interface here, and I'll drag on some more buttons. Go. And we'll call that one on 2. Make that 1 again. I'll call that one off 2. Make that 0. And this one now will make my device 2/set, and we'll update the other one as well to be 1/set. And we might actually want to put in a gauge to show the actual state of the two devices. So we can do that quite happily. If I stick a gauge in here, and gauge in there, and we call that number 1, and we do them between 0 and 1, call that number 2, and we do that between 0 and 1. And then we want to get the information from MQTT, so we'll pull 2 of those in. We'll do my device 1 status, and in here we'll do my device 2 status. And again we just drag those in, click deploy, and it will update the website. So now we've got these 2 gauges here and 2 sets of buttons. So if I have a look at this, if I turn 1 on, we should see that for some reason it's got the status wrong. What have we done here? That should be comparing that it isn't 0. So let's update that. Go back to here, on. And that's turned on, and it's set status to be true, which I've messed up again here because this isn't looking for my device 1 status. Should be, shouldn't it? Oh, okay, and it's just setting a Boolean value when it's actually looking for a 0 or a 1. So what we actually care about here is returning 1 and 0, 1 and 0. Put those on. Okay, so now it goes to 1, now it goes off. If this ever got disconnected, we would see that this wasn't updating anymore. Yeah, so you can see it happening. So this is all really nice. We now have remote control of whatever devices we want. But we can also send data back. So you might have seen that CPU temperature kept popping up once or twice, which was done with this MQTT publish. But we can just call mqtt.publish whenever we want with whatever information. So if we wanted to, for instance, detect when that button was pressed, it's as easy as writing setWatch. So if I say setWatch, and we'll look at the button, we'll look at the rising edge, which is when the button is pressed, and repeat it, and make sure that we debounce it. Because it's a switch, the actual physical contacts can vibrate, and we may get sent multiple times. And finally, we just want to check if MQTT exists, because if the button is pressed before any of this startup has happened, MQTT won't actually be there and we'll get an error. So we should see a little button press there, and we'll just send 1 as the data. And that's all we need. So I can copy and paste that and see what happens. If I press that, whoops, see a button press happening. And we should be able to pick that up in our menu here, and we'll also be able to see it in Node-Red if we care. So for instance, there are various ways to output things like this. One of them would be show toast, which is a little pop-down message. So if I do that, put another MQTT in, to my device button press, yes, stick that in there, update, and now hopefully when I press the button we'll see the little message appears down here. And we can, like we had with the CPU temp here, we can even log that just by dragging it onto a chart. And that's it. You can have as many of these as you want. You can also use Puck.js and a bit of software called Espruino Hub that will help to convert Bluetooth Low Energy to MQTT, and you can wire things up with that. Okay, so the one thing to add here is that everything that was in here so far was in RAM. If we unplug the USB, then when we put power back in again, it would all be lost. So ideally we want to avoid that. All we have to do is click upload, and it's uploading all of this code and sticking it in RAM, and then we just type save on the left hand side. And when you do that, it writes it all into flash memory, and it automatically restarts, runs on init, and starts the process of connecting. So all you have to do now is unplug it, and for instance now I'll take this and I'll plug it into a USB power bank. And you can see it's flashing away, it's starting to go through the process of connecting. So if we just give this a few seconds to connect and then go back to our Node-Red user interface, hopefully if I press a button it'll turn on. Turn that on, we can turn it off. And so you could run this off a USB power bank, or you could run it off something like a phone charger, which is probably a better way to have something that's running all the time. And you have a fully working system. I will cover in another video using something like this, which is the S on off, and flashing this with Espruino and using this to control whatever you want as well. So stay tuned for that one. If you found this interesting, please hit like and subscribe and check out some of my other videos. I should be producing new videos around about every week, all of them on fun microcontroller hardware kind of things. Thanks for watching.